All right, welcome to our 10th and final lab here for the Chem 1212 lab in North Georgia. This week we're going to be taking a look at the electrochemistry experiment, and what we're going to be doing is creating our own galvanic cell. So how we're going to go about doing that, we're going to use kind of this little small cylinder to set up our entire galvanic cell inside of, which might be a little bit different than maybe some of the textbook pictures you've seen that have kind of two separate beakers to set things up. For us, we're going to have kind of our rubber stopper that has a glass tube in it that's going to serve kind of as our second half cell to kind of get everything kind of put together for keeping our solutions separate. And as a starting point for kind of assembling our cell, which is what I'm going to kind of walk us through at the beginning, and then we'll get to the actual measurements and kind of what we can do with them a little bit later. In order to start setting up our cell, we're going to start by setting up the half cell that's in the glass tube. So in order to set up the half cell inside the tube, you're going to see I have one little itty bitty tiny piece of cotton at the very tip of this glass tube. I have that there, and what I'm going to do is I'm going to put the tip of this glass tube down into, this is a heated melted solution of agar. And so by doing this, hopefully what's going to happen is this agar solution is going to come up inside of my glass tube and also get just above the top of that cotton ball that I have down in the bottom of it. That's ideally what I would like to see, because that means if I get it to look like that and I have no air bubbles, which is kind of the other really big trick to getting this set up, as long as there's no air bubbles, the agar solution is able to conduct kind of an ionic current, but it's not going to let the solution or any water actually flow through that agar itself. So effectively what I'm doing here is creating the salt bridge for my eventual galvanic cell. And so if I go ahead and pull this out, she's been playing along already. And if I look at this, it's going to take a minute for everything to harden, and it might be difficult to see in the actual video, but my agar is up to here, or it's above my cotton ball. So this means I have everything kind of set up the way I want to let it dry. So I'm going to let this dry, the agar is going to harden, and again, the purpose of that cotton ball being there is just to give something more for the agar to kind of latch onto so that it holds in place a little bit better. And so that way we can have kind of an effective salt bridge that hopefully will keep any solution from going from the little glass tube into our bigger cylinder, because we do want those two to stay somewhat separate, at least physically from each other, so that we actually have our two halves to our galvanic cell. All right, now, the next thing we're going to do while I let that dry is I also want to prep the wires that I'm going to be using for this, which are basically going to serve as my electrodes for this particular galvanic cell. So we have two wires here. We have one that's pure silver, one that's copper. Hopefully you can tell the difference kind of in the video. Right? My copper wire is the one that I've also coiled to be able to tell the visual difference. This particular wire, obviously it looks copper, it's kind of the brass color. Silver one looks kind of nice, bright and shiny silver. Before we actually make our galvanic cell, we kind of want to prep our wires as well. And so what we're going to do in order to kind of have them prepped and ready for the galvanic cell itself, for our silver wire, we actually don't want it to be a bright shiny silver. We actually want the kind of a chloride coating to the outside for this thing to serve as kind of a silver chloride reference electrode. And so when you see like reference electrode in your actual data tables, where it's like that 0.210 volts, that's your reference electrode for both parts of your experiment. In case you're looking at the data table and not sure why it looks like it cuts all the way across, it's the same value for both trials. And how we're going to generate basically that electrode, we're going to take the silver wire, and for this lab we have a couple different acid solutions we're going to use. We have one that's concentrated nitric acid, which is currently clear. It might change in a moment when I use it. And then we have a mixture of nitric acid, hydrochloric acid, and water in kind of a 1:1:1 ratio. I'm going to dip the silver wire in that acid mixture with the nitric and hydrochloric. Hopefully what that's going to do, I have nitric acid in there, that can potentially oxidize some of our silver, which will then make it so that any of the chloride ions in the solution can now interact with the silver plus cations that are forming, and we can make a silver chloride coating. And ideally what happens if I dip this in the solution for, kind of swirl it around for just a little while, hopefully what I'm going to get out of this is that I'm going to get kind of a darkened coating to the bottom of my wire. We want that wire to look darker on the bottom than it did before. And if you've noticed, it's kind of a duller black. I'm probably going to go and wash it through just a little bit more, just to make sure that we have that nice kind of silver chloride coating to it. And then when I'm done with that, I can go ahead and rinse that. I don't have something set up right here, so I'm actually going to walk over real quick to the sink, just go and rinse this out. But you'll notice there's not really much on here, so I'm not in really danger of spilling any concentrated acid or anything. But I'm going to go ahead and just give this a very gentle, quick rinse of water. Shouldn't wash off any of the silver chloride coating. Silver chloride's not very soluble in water. So now if you look at this wire, hopefully it's a little bit more visible in the video. Over here where I've been holding it, it's still pretty clear, but the part that I dipped into that acid solution is now much darker. So I have that silver chloride coating to this electrode. And that's the part that I'm going to want down in the solution when I go to set up my overall galvanic cell here in just a moment. All right, so my next piece, I'm just checking on my agar. Looks like it's pretty close to being dry. We'll come back to that in just a moment. For my copper wire, this is a pretty much brand new piece of copper wire, so I shouldn't have to do this too much to try and clean it. But we want our copper wire not to have any kind of oxidized coating on the outside, so we actually want the copper wire to be really shiny. It already is, but in the case that you have an older bit of copper wire that might be partially oxidized, has kind of some black or grayish, kind of almost maybe a dull surface to it, what you're going to do is you're going to rinse that in the concentrated nitric acid. What that's going to do is basically take off any of that kind of oxidized coating that you have on the outside, and leave us with kind of a nice, bright, shiny copper piece of wire. And as I do this, you've probably seen that concentrated nitric acid solution change colors. If you remember a little bit from earlier this semester, what happens to copper wire when you put it in nitric acid? That's probably more than long enough for me to put this in here. Again, I'm going to take this over to the sink in just a second. I probably should have a beaker over here. If I was making students do this, I probably just have a waste beaker that you can take a squirt bottle to rinse this with real quick. So that's what I'm going to do in the sink over here. So I'm going to take this, rinse this off just a little bit, the last little bits that I have here. And ideally, what I'd have people do is be keeping this in a waste container, which is actually what I do have sitting over there. And because anything that has color to it, as far as kind of like solutions, things like that, you ideally want that to get into waste. Copper is not something you usually want to send out the sink, so things like that, we'd want some kind of waste container set up to be able to do that. All right, now, the next piece of this, as far as what we're going to do, to set up the rest of our overall cell, what we're going to do, now that I have my agar that's kind of hardened in place here, just take a little bit off those on the outsides. What I'm going to do is I should be able to now fill this little glass tube, and I'm going to fill it with a saturated potassium chloride solution. And so I have a potassium chloride solution, and actually in this case we have a little bit of silver chloride in there as well. And what we're going to do when I actually go to make this, and I'm going to go grab a pipette here just to be able to do this cleanly. Apologize, so I'm going to kind of duck off screen for a second to grab that. So I'm just going to take a little pipette, take a little bit that I can pull up into it, and then what I'm going to do is go ahead and mostly fill this little inner glass tube. Doesn't have to be filled all the way. Usually, as a good rule of thumb, I'd say you can probably fill it to the bottom of your stopper. That should be plenty high, because we really just want the silver wire. The silver wire we want to be able to stick out the top enough that we can basically grab it with an alligator clip when we go to make our voltage readings. But we also want the bottom of the silver wire in this solution, right? And that's what's going to keep everything kind of connected with the salt bridge linking or different liquid solutions as well. Right, so once I have this part set up, one thing I do notice as I've kind of done this already, as I'm looking in here, I actually notice I have a couple of air bubbles sitting at the bottom. Those air bubbles can kind of throw off some of our measurements a little bit later, so I'm going to try my best to just kind of get a little bit of those air bubbles out. And I'm actually going to take the copper wire to do that. It's a little bit longer, maybe. Straighten it so I can actually get it down far enough to do that. But by getting out this air bubble, that air bubble won't throw off any of my measurements that I eventually go to make with my voltmeter. All right, so to apologize for the cut there. I didn't want you to sit there and watch me struggle and make the copper wire long enough to actually get the air bubble out, but that's basically all I did. As I got the copper wire down here, just kind of poke out any of the air bubbles from the bottom of this. Because those air bubbles, like I said, they will really mess up kind of the conductivity for the electrical conductivity of your salt bridge, and it will make some of your readings, you might see a reading that looks about in the right range for a brief second, and then all of a sudden it'll basically not be there anymore. And you'll basically get readings that are very close to 0 volts, which aren't really what we're expecting. We're not going to get huge voltages when we go to measure the voltages for these galvanic cells, but we should be getting bigger than 0. All right, so at this point, I should have one of my half cells basically set up and ready to go. All I have to do now is add my actual electrode, which is the silver wire, which you can see where I've just placed that. There you go. And so the only thing I want to be careful with my silver wire, I want to make sure the dark end is what's going to go down into that solution itself. And I want to put it down far enough I can see the wire in the liquid that's in this cell, or in this glass tube. And I'm actually going to bend the silver wire just a little bit at the top. It makes it really easy for it to just basically be able to sit there and not fall into the glass tube itself. And it will also give me a nice, easy spot to kind of clip onto when I go to make my volt readings here in just a few moments. All right, now, one of the other ways you can try to make this wire stick here, and this is also perfectly valid if you don't want to bend these silver wires, which I don't recommend bending them too much, simply because they are easy to kind of break, and it's annoying to have to kind of keep making new silver wires all the time. It's not the cheapest thing in the world. But you can use parafilm. It's kind of like almost like a very waxy, stretchy, sticky paper. You can actually use parafilm and kind of wrap it to make almost like a ball, and just leave the top of the silver wire exposed and put it down as well. I think that's the way the lab procedure actually shows it in the manual. I think it's just maybe a little bit easier. You can almost just bend it here. The parafilm is not always necessary if you kind of know how to set it up and kind of what you're looking for the setup of your solution. We just want the silver wire into our actual KCl solution here, a part exposed to the top for us to clip to kind of connect our entire circuit at the end. So that part of the cell should be good. Now the other part of the cell is going to be my copper wire in terms of my other electrode. And so for it, I'm actually going to put it in through the bottom, leave my coiled part down. Oops, as I drop my copper wire. Sorry. So with my copper wire, what I'm going to do is stick it up through the bottom and kind of do the same thing. I'm going to bend the tip of it just a little bit so that it won't fall down into the solution either. And now I have a tip of my copper wire that I should be able to kind of clip onto once I have my cell completely set up. All right, now the only thing that's really left at this point is to kind of finish assembling the last little pieces of the cell, which is basically to slide everything down and kind of be able to kind of close everything. But we need a solution in here. And so this is the part that's going to be different for our two different trials. So we have two different trials that we're actually going to be measuring. And really, as far as all of the measurements for this whole experiment, there's only 3 values that we're going to be looking for. One of them, the lab actually already knows what that value is. That's going to be the concentration of the copper sulfate solution. So the copper sulfate solution right here, about 0.100 molar. So that's the concentration of the copper sulfate solution. The lab already knows that, but that's what you should be using for your calculations, just to kind of make sure you know what that solution is, because it is kind of buried in the procedure if you're going to go find that value to use later on. All right, now the next piece of this thing, I'm going to go ahead and actually take this copper sulfate solution, and I'm basically just going to fill my large cylinder with the copper sulfate. And I want it to be filled just high enough so that my wires and my glass tube are all submerged. So in this case, that should be plenty high. My copper wire is now down submerged in the solution. My glass tube is also down in the solution. And so now I have a kind of completely sealed overall galvanic cell where I have basically 1/2 cell is this copper sulfate with the copper wire. My other half is that kind of potassium chloride, silver chloride solution that has the silver wire in it. And now to just complete kind of the whole galvanic cell and complete the circuit, now I can use my voltmeter from the LabQuest. And so at this point, now is the actual measure values that we're going to be making. So we're going to make our measured value using our voltmeter, which if you turn on your LabQuest and are looking at it, your LabQuest hopefully should identify that it's trying to read a voltage. So you'll see a screen that hopefully looks something like this. Inside a red box, you'll see it reading a voltage to 3 decimal places. So what we're going to do here, in terms of hooking up our wires, I can get these untangled just enough so I can actually use them. Which clamp you put to which wire does actually matter. And I'll point that out because if you have them reversed, this will help you with one of your questions later on. Actually, I just put them in the reverse order. I'll show you how I know that in just a second. So I'm clamping the black wire, the black alligator kind of clip, to the silver wire, the red one to the copper. And notice I'm getting a voltage reading here of about 0.095 volts. 0.094, looks like it's pretty stable there, so I'll say 0.094 volts. So that's going to be ECell 1 in your data table. And the way your data table is set up, it might look a little confusing at first, but the whole left column is all for trial 1. The whole right column is all for trial 2. So cell potential for trial 1, 0.094 volts. Now, if you set these up backwards, which is kind of what I did at the start there, because I forgot to look which way I was supposed to set up at the beginning, but this is where kind of just general knowledge helps a little bit as well. By putting them on backwards, you're not going to get a different measurement, like numerically, except the sign will be reversed. And so you get a negative voltage instead. If you get a negative voltage, that just means things are going the opposite direction of how you kind of hooked things up. And so that's kind of something to kind of keep in mind. Galvanic cells, if it's truly a galvanic cell, remember a galvanic cell is a spontaneous chemical reaction, which means your cell potential should always be positive. So if it's a galvanic cell, your cell potential should be positive. If you're getting a negative reading, you've probably got your clips backwards, but the number should stay the same. All right, so that's it for trial 1. We don't have to do anything else. All we're going to do is get rid of our solution into the waste. So we're going to get rid of our solution into waste, which I'm sitting off screen back here, unfortunately. And now, for part 2, I'm going to use this copper sulfide solution. And I'll rinse out that cylinder in just a second a little bit. So the copper sulfide solution, that we're going to use for part 2, this is a saturated Cu2S solution. And what we're going to be trying to do, and kind of the goal of the second part of this experiment, is to actually find the KSP of that copper sulfide. And it is not very soluble. The KSP is really tiny, so if you get a really small number, that's kind of what you expect for this particular experiment. But how we're going to do that is we're basically just now going to use this solution as our other solution for our half cell. Right? We had the copper sulfate solution in here before. We're just going to put the copper sulfide solution in this time. Again, make a reading of the voltage. In part 1 with this copper sulfate, your goal was basically just to figure out what's the reduction potential for copper 2+. And the calculation section of the lab does a pretty good job, I think, of walking you through how to do that calculation. In the second part, you do something very similar. We're going to measure the cell potential with the copper sulfide, except we're going to give the copper +1 reduction potential. And if we have that, we can actually relate the copper reduction potential and use that to figure out what's the concentration of the copper plus in the solution. And if you know the copper plus concentration, you should be able to find the sulfide concentration in a similar way to how you did things last week for the KSP lab. And then once you have the concentration of both the copper and the sulfide, you should be able to find the KSP that way. And again, if you have questions on that, the lab does a pretty good job walking you through, but feel free to email myself or your instructors as you're going through those calculation steps. Probably the biggest thing just to remember, it's Cu2S. So once you find your copper concentration, the sulfide ion concentration is half that much as you're setting things up. And then remember, it is an equilibrium constant. The copper concentration will be squared in the calculation. So like I said, copper concentration will be small. Your NKSP will be really small once you kind of get all the numbers crunched for that. All right, now showing that, like I said, I do want to wash out the cylinder, and I'm actually just going to grab a clean cylinder to make this just a little bit easier for us and a little bit faster, so you don't have to wait or don't have to cut the video too many times. So for the second solution, we'll do the copper sulfide. And we're just doing the same thing. I'm going to fill this high enough that my wires will get into the solution. And now, I'm just going to go through and clip my wires again. Should be able to go through and look at my voltmeter. And so I clip, again, black on the silver, red on the copper. And if I look at my voltage, I'm getting about 0.070 or 0.069. Looks like 0.070, maybe a little bit more consistently. It's kind of bouncing back and forth between those two. You can take an average over time. Just looking at it from my end, it's staying pretty close to, I'd say 0.070 is what it's at most consistently. So 0.070, that's my reading for the second trial. And that's it in terms of data recording for this particular experiment. All that's left at this point is just kind of clean up things, which is, again, really just kind of waste disposal. We'll keep all of our copper waste together. Copper, again, can't really go down the sink. Then we'll clean off our wires, put them back. They're reusable. And as far as the rest of this, like acid solution stuff, we have acid waste that we'll take care of. Everything from our end when we're handling those as well. But that's it experimentally. Everything else in this lab is just calculations. So we have just those two measured values. We had the first reduction potential, which was at, what was that, I already forgot what the value was, 0.095, I think, volts, or 0.094 volts. And the second one was 0.070 for the voltage. So those are the two voltages that we read. The second one's maybe a little bit higher than we normally see. I think I usually see maybe just a little bit smaller than that, but that's fine. We don't expect really big values for these voltages. And this copper sulfide solution, like its solubility, like I said, it's really, really tiny. As you do your calculations, it's probably what you'll see out of that as you get kind of towards the end. All right, so that is everything that I have for this week. And this, like I said, this is our last lab for the semester. So if anyone has questions, you're kind of wrapping things up as far as like the experiment, the calculations, things like that, or anything grade-wise overall, feel free to reach out to myself. Your all the individual lab instructors will be happy to help and answer questions. And hopefully everyone's had a good semester. I know it's been a very weird and strange one for all of us. Hopefully everyone's got a little bit adjusted, and hopefully we'll all get to see each other again then in the fall. Right? Have a good one.